Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about diazenes. Diazenes are the six-membered heterocyclic compound derived from benzene by replacement of 2 CH group by 2 nitrogen atom. This replacement results in 3 isomeric forms, 1,2 isomer, 1,3 isomer and 1,4 isomer. You can see here benzene. In this benzene, replace 2 CH group by 2 nitrogen atom. Then you will get diazene. Now diazene have 3 isomer, 1,2 isomer, 1,3 isomer and 1,4 isomer. Now nomenclature of heterocyclic rings will be done by 3 ways. Common name and replacement nomenclature. Common name, you know that common name of these 3 isomer is pyridazine, pyrimidine, pyrazine. And replacement nomenclature, you can see here benzene replace 2 CH group by 2 nitrogen atom. 1,2-diazabenzene, orthodiazabenzene, 1,3-diazabenzene, metadiazabenzene, 1,4-diazabenzene, paradiazabenzene. This is the replacement nomenclature. Why it is called replacement? Because you can see here the nomenclature ending benzene, and then we are putting the position 1,2-diazabenzene. So this is the replacement nomenclature. Now Hansch-Widman nomenclature. Hansch-Widman nomenclature contains prefix, ring and suffix. Prefix plus ring plus suffix. Prefix means type of heteroatom, just like in this case nitrogen. For nitrogen we are using aza. Then ring, size of the ring, 6-member ring in this case, so we are using in. And suffix, degree of unsaturation of ring. So aromatic we are using E. So nomenclature become azene. So there is a 2 nitrogen, then we called it 1,2-diazenes, orthodiazenes, 1,3-diazenes, metadiazene, 1,4-diazene and paradiazene. Now diazene compound belong to the category of pi deficient ring system, similar to pyridine. You know, my friend, diazenes are aromatic in nature. A lone pair on sp2 hybridized on nitrogen are not involved in aromatic section. You can see in this orbital diagram, lone pair not involved in the resonance. Now diazenes are weaker base compared to pyridine due to inductive and electron withdrawing effect of second nitrogen atom. This is very important for multiple choice questions. Diazenes are weaker base compared to pyridine due to inductive and electron withdrawing effect of second nitrogen atom. So pKa of pyridine 5.2, orthodiazene 2.3, metadiazene 1.3 and paradiazene 0.6. Now pyrimidine. Pyrimidine ring system has wide occurrence in nature as substituted and fused compound which include nucleic acid and thymine, vitamin B1. You can see here adenine contain imidazole and pyrimidine. Vitamin B1 contains pyrimidine and thiazole. So pyrimidine ring has symmetry along C2 and C5. In C4 and C6 as well as N1 and N3 are equivalent to each other. Now pyrimidine ring has the following resonance contributors, and positive charge will be placed on the 2 and 4 and 6 position carbon. You can see pyrimidine structure 1 where position of nitrogen 1. It is resonance of this 1, 2, 3, 4, 5, 6, 7. Now synthesis. Acid or base catalyzed condensations, reactions of 1,3-dicarbonyl compound with imidine or guanidine yield pyrimidine derivative is known as pyrimidine synthesis. You can see in this reaction scheme the 1,3-dicarbonyl, because carbonyl group present at 1,3 position, and NCN types compound which is guanidine or imidine, then it will give the pyrimidine. Now mechanism, you can see the lone pair of electron present on nitrogen approaching at electron deficient carbonyl carbon, and then formations of nitrogen carbon bond, and then dehydrations, you will get this imine, and further 2 steps you will get the pyrimidine. So by applying Pinner procedures, variety of pyrimidine derivatives can be prepared from different 1,3-dicarbonyl starting material like acetylacetone and ethyl acetoacetate. You can see 2,4,6-trimethyl pyrimidine, 2,6-dimethyl 4-hydroxy-pyrimidine. So pyrimidine derivatives can be used, can also be prepared from enol ether by replacing 1,3-dicarbonyl compound. You can see in this scheme formations of 2-dimethyl 6-hydroxy 5-nitrile pyrimidine. Now from condensations reaction of malonic ester with urea in presence of base yield barbituric acid. You have already read in in part 2, which tautomerizes to trihydroxy form. Finally, reactions with phosphoryl chloride followed by refluxing with hot water and zinc dust yield pyrimidine. So you can see here the reaction scheme and formation of pyrimidine. So 2-substituted pyrimidine can be prepared by condensation followed by cyclization of carboxylic acid and 1,3-diaminopropane. Subsequent dehydrogenation in presence of catalyst gave 2-substituted pyrimidine. So you can see here the reactions and base facilitated trimerizations of alkane nitrile with free methylene group adjacent to the cyano group results in the pyrimidine 4-amine derivative. You can see in this reaction scheme, after using 3 molecules of acetonitrile in presence of base, it will give the pyrimidine ring. Now reactions of pyrimidine. Pyrimidines undergo reaction at nitrogen as well as at carbon similar to the pyridine. Electrophilic addition reaction like protonations and alkylations occurs at ring nitrogens. Electrophilic substitution reaction less facile because of decreased basicity. Under favorable conditions, reactions occurs at 5th position. You know, my friend, nucleophilic substitution takes place at 2 and 4 and 6 positions. So what is the theme of this slide? The theme of this slide is where is the reaction occurs in pyrimidine. So this is the position of carbon 246 and nitrogen. Now reactions at nitrogens. Electrophilic addition at nitrogen. Lone pair of electrons on the rings nitrogen undergoes electrophilic addition reactions with the electrophile only at one nitrogen, and under drastic condition both nitrogen undergo electrophilic addition, and this electrophilic addition results in the formation of pyrimidinium salt. You can see both are aromatic. Now protonation at nitrogen. Pyrimidine nitrogen form monoquaternary salt with mild acid and diquaternary salt strong acid. So alkylation at nitrogens. Pyrimidines react with alkyl halide to give monoquaternary salt less readily compared to pyridine. Dialkylation cannot be achieved with simple alkyl halides. However, more reactive trialkoxonium tetrafluoroborate convert pyrimidine to diquaternary salt. You can see in this mechanism. Now reaction at carbon. Electrophilic substitution at carbon. Electrophilic substitution of pyrimidines is very difficult. Hence pyrimidines are bad at undergo electrophilic aromatic substitution, but under favorable conditions, pyrimidine ring react with electrophile only at 5th position. You can see the position of 5th. At 5th position, no positive charge, hence it has some electron density. So you have to write the resonating structure and you can see the situation. So activating group alkyl OH OMe on pyrimidine ring increase basicity and assist in electrophilic substitution reaction at 5th position. So nitrations, halogenations and azo coupling. Now nucleophilic substitution reaction. Pyrimidine undergoes nucleophilic substitution reaction easily at 2, 4 and 6 position. Nucleophilic substitution of hydrogen next to nitrogen requires oxidation of resulting dihydroproduct to get pyrimidine. You can see dihydroproduct and 4-phenyl 1,6-dihydropyrimidine. It gives under oxidations 4-phenyl pyrimidine. So nucleophilic substitution of pyrimidine are very susceptible for nucleophilic addition. Pyrimidine convert into pyrazoles by reactions with hot hydrazine. You can see how ring contraction occurs. So my friend, I hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.